Good day everyone. How satisfying it is to see your kiln running at full capacity. But of course, the possibility of failure always lurks, especially when refractory spalling occurs, or it wears down, or collapses and red spots appear. This could happen anywhere on the shell. We're confronted with the eternal question: stop the kiln or keep it running? To continue operation, we must cover the red spot, and this video deals with just that. Let's first look at the location of the spots to understand when to stop the kiln and when we can use the technique as explained hereafter in the video. It is important to detect refractory failure as early as possible, and for this we rely on shell scanners and handheld parameters to monitor shell temperatures. A few words about the kiln shell fans. Ideally, they should be fitted with such a nozzle and be set at a slight angle to the shell to cut away the heat waves on the shell surface. Theory says that this laminar airflow is preferred to a turbulent one when the fan is perpendicular to the shell. Let's look at the hotspots location and start with the calcination zone, typically fitted with high alumina refractory bricks. There is no liquid phase nor coating formation here. Occasionally, circulating elements condense onto precalcined material and stick to the refractory. Simply put, if the spot is small, about 4 to 6 bricks large, and not too hot, under 400 Celsius, then the shell can be cooled down with a fan, the main burner moved back 30 centimeters, and operation can continue. But as soon as the spot continues to grow, stop the kiln immediately. The procedure of this video cannot be used in such cases. We continue with the safety zone and high transition zone, normally fitted with magnesite refractory. Here liquid phase has started and the spots can be covered with the procedure described in the video. Spots under or near the tire. In such events, stop the kiln immediately. If not, the shell will get deformed and this kiln section will have to be replaced, with the added difficulties of removing the tire, installing it on the new kiln segment, while stabilizing the two open ends of the kiln. Case of hot spot around the complete kiln shell circumference. Stop the kiln immediately. When one or more rows of refractory fail, the upstream rows will tend to slide down towards the discharge end, weakening the entire refractory lining. As a result, instead of changing just 2 or 3 meters of refractory, 10 or more meters will have to be refitted. Spots in the sintering zone. Because of the high thermal load and being far away from the kiln inlet, the procedure described afterwards may not cover the spots. However, changing the main flame shape, reducing radial component, or moving the burner in or out 10 cm, depending on spot location, will help coating to form and cover the spots. This is a high-risk location and procedure can be used only on small spots. Finally, spots in the cooling zone or discharge end of the kiln. Even when these spots can be covered with coating by reducing the cooling zone length, moving the burner out 30 centimeters, and overheating the burning zone, there is a risk of burning the plates of the kiln discharge lip and damaging cooler plates. The method in this video does not apply here. It is advisable to stop the kiln. The situation leads us to a critical decision. We're keeping the kiln running to supply a high cement demand may cause permanent damages to our kiln shell. Or do we have a low refractory stock and need to delay the major shutdown? Before going into the procedure itself, let us have a look into the kiln to better understand what will happen. We see a kiln cross-section with the kiln shell, the refractory and a bit of coating, somewhere in the sintering zone with magnesite refractory. The melt has started and clinker phases are in the making. For clarity, there is no flame nor material in this view. In the kiln, temperatures are above 1680 Celsius. In the coating, it goes down to around 1480 Celsius. Then this heat dissipates through the refractory, the shell, with readings of around 280 Celsius. With a loss of refractory as seen here, the shell temperature will reach 380–400 degrees Celsius or more. When going above 410 degrees Celsius, the kiln must be stopped immediately to avoid permanent deformations to the shell. The liquid phase normally sticks to the refractory, forming our coating, but does not combine with the kiln shell, thus cannot form proper coating. The idea of the procedure is to create an excess of liquid phase rich in iron, which will set and hold onto the shell. This procedure was prepared and successfully implemented by the author, Oscar Chirinos Manrique. Please pause the video to read this disclaimer. For additional questions, you may contact the author or write a comment on this video. When a hot spot has been detected, inform shift personnel of the procedure, specifically the central control room operator, the shift supervisor, process engineer, and the production manager. Nominate a responsible to control the procedure. Fill up bags, jute bags or cement bags with iron ore, 25 to 30 kilograms each, or use a skip bin, a dumpster, or old grinding media drums. Bring bags, drums, at smoke chamber level on preheater platform. Prepare the equivalent of 15 to 20% of the kiln daily production rate in kilograms of iron ore. Example: 3,000 ton per day kiln, 450 to 600 kilogram iron ore. Addition of iron ore, flux, can start now. Operator is to monitor the O2 level at kiln inlet and keep it stable. Open register at smoke chamber. Add bags or shovel in iron ore as quickly as possible. Keep an eye on kilowatt of main drive. Kiln feed and speed will have to be reduced because of false air at kiln inlet and system cooling down. When finished adding ore, close register. After 25 minutes or half an hour, kilowatt main drive should start increasing. Slightly reduce main firing till reversing the kilowatt trend and seeing reduced hotspot color and temperature. O2 levels will be slightly high. Restore fuel, feed and speed by steps, keeping stable conditions of kilowatt and O2 levels. This flux curing procedure will help to postpone the major kiln shutdown at least for a few days. With stable feed quality and firing conditions, this patch will last longer. Remember to always comply with the safety regulations of your plant, in particular when running this red spots flux curing procedure.